Hi everyone, so this is the front of our cabin in a town called Brownsfield, Maine. Town is actually probably a strong word.
Our location is right around here at 500 feet, just across the New Hampshire-Maine border. These lumpy things are the White Mountains, and their elevation goes up to 6,000 feet.
I'm going to teach you a method, a tried and true method in geology. You could call it float mapping, maybe you could call it ass mapping. It's a way that you can get a kind of survey of the regional geology without leaving your chair. Right outside the cabin, they have a fire pit. I'll tell you that this is an igneous rock, granite. The black stuff to me looks like hornblende, and there is a load of feldspar and quartz. I would say that this feldspar is mostly plagioclase. Some of the stuff I might argue looks almost more dioritic. This one has smaller crystal sizes. The way in which the crystals kind of are interlocking to me is what lets me know it's igneous. So that's some nice interlocking, crystalline, intrusive igneous rock. It's got to be old, right? This stuff crystallizes under the ground and it takes a while to come to the surface. I could do some reading, but I know so back behind the cabin, there's a river. I'm actually a good ways up from the river. This could be 3 or 4 meters. And there's this path that I'll walk along that follows the river for miles. And you stay at this kind of elevation above the river. It's so kind of linear and beautiful that you think it's man-made, but this is actually a natural structure called a levee. Maybe you're familiar with the Led Zeppelin song. What we found, it's a really sandy, kind of elongate feature, fairly coarse, and this is only possible, that's not really focusing, if the river's in flood, right? So its ability to carry sediment is dependent on the speed of the river flow and the water depth. And the building of this feature is actually related to water depth. So the river is flowing over its banks, and if you think about it there, it's going to be its shallowest. And whenever it's shallower, it loses its ability to suspend sediment. So it falls out right on top of here. And some percentage of floods are able to top this. And so every year, this feature is actually getting taller. And it works to naturally constrain the flow of the river. You can see here, down 3-4 meters to the river. This path is along the levee, and beyond it is the swamp, the floodplain. You can see that by a few meters, the levee is the highest elevation part surrounding a river. And so this actually explains a lot of settlement patterns alongside the Mississippi. All of the major towns, Baton Rouge, New Orleans, Lafayette, are built on levee deposits, because it kind of feeds back, and it eventually ends out that the levee is the safest place to live to an extent.
So we're just going to summarize here using Google Earth, but this is a satellite image of the same river. And so repetitive flooding deposits sand just on the banks of the river channel, making a levee. These are sandbars that act to kind of confine the channel. And they accumulate over time, the sand does, and it makes for a surface here that's high elevation and thus forested. And beyond that high elevation surface lies the lower elevation floodplain. And this gets filled with water probably every year or every couple years.